Right now, what you see on my screen is the topic summary. Probably you would have received a detailed topic list from your consultant. This is exactly what we are going to cover in this course, right? So initially, there are some prerequisites for DevOps. I mean, before you start with DevOps, there are few topics which you need to know. You need some operating system level knowledge. We are covering Linux. Basically, you need some Linux knowledge, and we are covering Linux because mostly the commonly used machines are in Linux than Windows. So DevOps has a lot of chances in Linux field than Windows. But of course, DevOps is not anything operating system oriented. It is something like a different time, a different culture. uh, but you need a operating system knowledge to start with, and in our course we are focusing on Linux, right? uh, One second.
Hello?
Yeah, one second, I'm sorry.
Hello?
Yeah, I can hear you. Just give me one second. I was just hello, am I audible now? Am I audible? Hello, guys, can you hear me? Just ping me in the chat if you can hear me. Hello guys, is my voice break? I'm sorry about that. I think I got disconnected for a while. Am I audible now? Or do you find my voice breaking? Let me know.
Yeah. Yeah.
Okay.
No.
So while I am talking, if you find any problem with my voice or anything, please, right? So what I said is, these are the topics that we are going to cover. So before we move on to DevOps, you would need some basic understanding about operating system and software applications. So that is what we are going to cover in the initial, and also some scripting. So that is what we are going to cover in the first maybe 2 weeks. There would be a Linux basics. So we would find out what is Linux and some basic commands that you are using in Linux, and also some scripting. Basically, you can write some scripts in Linux. It is called shell scripting or bash scripting, that we will cover, and also some intermediate level or basic level Python programming also we are covering, and also some software topics, how you would run a web application, how you would run a website, how you would run a website. Those things we are covering in our next topic. So these, and also some database topics. These are not detailed topic, but the topic detailed enough so that you can get started with. You need to know some system administration or Linux administration before we can actually jump into DevOps. Otherwise, the concepts you won't get it very easily. So initially for 2 weeks we would be covering that, and after that we will move on to cloud computing. We are covering AWS. and that would also take about 15 hours of training. AWS is a leading cloud computing provider today. And after cloud computing, we will move on to DevOps. Even this Git and are also DevOps topics. Git and Jenkins, Docker, Vagrant, Nagios, Chef, Nexus, Sonar. These are some tools, some DevOps tools that we are going to cover in our course. And out of this, Vagrant, Nexus, and Sonar are not pretty detailed. Remaining all remaining tools are pretty detailed and some job oriented. So whatever tools that we are learning, it is a practical course. We would take a sample project and work out these tools on that project. So you would get a clear overview about the work, what all things you would do when you work as a DevOps
Hello.
engineer. So I would start now.
Sir,
So
what about the Mavins?
Maven,
Yeah.
we are not covering Maven. We are covering Ant is a similar tool. Maven is
Oh,
a
okay.
build tool that you use for building the code into an executable code. Ant is a similar tool.
Okay.
So we are covering
Okay.
Ant actually. Yes.
Okay. Oh, okay. Thank you.
So about AWS, I will talk about what is cloud computing. The basics is nothing. Basically, you would find out what is a database and what is a application, how you would run your website, and when you access your website on your browser, what all things will happen, how these websites are actually working, or when you try to book a cab from your mobile phone, what is actually happening in the background. So these are the basic things that we are going to cover before we start with DevOps and cloud computing. So after we covered these things, these are the advanced topics: cloud computing and DevOps. So into the cloud computing, I will talk about what is cloud computing so that you would get an overview. I'm not going into each and every services in cloud computing, but just an overview about it. So in all days, right? Basically, what is computing? The computing means you know what is a computer. The computer would have a CPU, it has a memory, it has some memory, and it has a hard disk, and you can run your software applications in a computer. That's what a computer is, right? And example is your laptop. All of you have one workstation where you are running some application. The application's example can be your browser and stuff, right? And similarly, sometime you want to run your computing on a remote place. Basically, you are in a situation you want to run a website. You need your own website, and this website need to be run on a machine which is highly available. For example, this machine should have proper internet connection 365 days 24 hours, and it should have a very good hardware so that I'm not going to turn off this machine ever. The machine is going to run maybe 3 or 4 years continuously. I will not shut down that machine. So the machine hardware should be powerful enough. They don't get heated up or anything. It should be very powerful hardware. And also there should be a the machine should be kept in a very good AC, a ventilated room with a good power backup. So there are a lot of things that I need to take care, right? There are a lot of things that I need to take care to make sure that everything is looking good. So if I have to set up such machines myself, that is going to cost me a lot of money because I need connection from 3 or 4 internet service providers so that if one connection is down, other connection will pick up. And I need a very good UPS and stuff which will never go down. Otherwise, if it goes down, the machine can go down. And I need a very good internet connection, a well connected machines and everything should be there. So it's all very costly. So what people used to do is there would be a third party, and what this third party do is they would set up these facilities for you. So they would have a good AC ventilated room with a powerful AC, powerful backup, and powerful internet, and very powerful machines. And these machines can run 3 or 4 years without any problem. And it can let's say I want to run a website on that machine. I can actually buy one machine from this third party vendor, and I can run my website for lifetime. Right. So traditionally what people used to do is these are called data centers. People would set up in some geographical location, maybe in United States, California. They have a building where they have these machines, right? And it is me. Let's say I want to run my website. This is me on my browser. I want to run my website. So what I will do is probably this guy will have a website. I I can go to their website just like I would order some item from AWS. I can order a machine from this data center. Then I will get one of the machine, and they will send me the login credentials to those machine. Then from my local computer, maybe I am in Bangalore, from Bangalore I remotely log into this machine. Then I will set up my software there, and now people in the world can see my website. This is the machine that will serve everyone on the internet with my website. Whoever is requesting my website, they can get the website content from this machine. Of course I need some extra configuration also. I am not talking about that. So basically you would come across some situation whenever you are running some business. You would come across some situations where you need a number of machines where you want to run your software, and it should be available to the people. People are nothing but your customers, so your software should be available to the people. So you need to run the software in a set of machines which is highly available. And this was how the process was like 10 years back. This was how people would buy dedicated machines, because they cannot have such a setup in their home. So typically they would buy the machine from a third party data center who would sell the machine maybe for a monthly cost. So monthly I have to pay some $30 or $50, and I have to pay it every month, and that machine is mine. And the problem with this approach was actually, let's say you are ordering for one machine. Let's say I'm ordering a machine which has 8 GB of RAM and 4 CPU, 4 CPU cores. So I am ordering a machine like this, and at that time the data center may not have that machine with them. What they will do is they will go to the shop, or they will place an order for that machine. They will get the machine. They will take the machine into the data center, and they will install the operating system. Let's say I requested for a Windows machine, so they will install the operating system. And finally, once the machine is up and all the softwares are installed and all the drivers are set up, the data center guys will send me the login credentials, and using these login credentials I would remotely log in from Bangalore to this machine which is located in California or maybe a different part of the world. And this approach had a lot of disadvantages, because obviously when the software became very complex and it was growing, the demand has increased. Basically people cannot wait for 2 or 3 days until their machine is delivered. They want to be able to increase their I mean, let's say when they are in need, they should be able to add more machines as per their demand. For example, think about google.com website. There are billions of people accessing google.com website, so there should be 10,000s of machine to serve that many people, because a single machine cannot serve 1 billion people. So there can be a number of machine that is serving 1 billion people, maybe 10,000 or maybe a lakh of machines. So that many machine Google might have. If the number of traffic increases, Google immediately want to add more machines so that it can handle that traffic. So otherwise google.com website itself can go down. So probably you might never have seen google.com going down ever. It does not mean that uh, their machines are not getting overloaded. It means that even if that happens, Google has the capacity to increase the number of machines on demand basis. So that is how companies, software vendors today expect how their infrastructure need to look like. They should be able to add a number of machines whenever they want to. So in the next 1 hour, I am expecting a high traffic on my website. I should be able to add more machines immediately so that my infrastructure can handle that traffic. So due to this, due to this requirement, people realize that this traditional computing model might not work anymore, and people moved towards cloud computing. With cloud computing, it is instant. Whenever you want to create a machine, all you do is you would log into a cloud computing provider's website. You click on a button, create a new machine. Then they will ask you which operating system you want, how much RAM you want, how much CPU you want, everything you would select, and you click on create machine, and the machine will get created in 2 minutes. Right? It is that much fast nowadays. The After the invention of cloud computing, it is that much fast. So actually what happens is, when I am ordering a machine, probably my machine is getting created inside another existing machine. Let's say this is a machine which the data center guys have, and probably it has a very powerful hardware and maybe 512 GB of RAM, and I need only 8 GB of RAM. So what happens is, part of this machine's hardwares are shared with my VM. So a virtual machine would get created inside this actual machine, which will have 8 GB 8 GB RAM for CPU and the operating system whichever I am requesting for. But it is not a actual machine; it is a virtual machine. But I don't care, because I get the machine, I get the enough computing power. That is what I care for. So, and if I am getting the machine very fast, I would rather go for a virtual machine rather than buying a actual machine. So this is how the computing work nowadays. It is not just the machine. If you want to create a network for yourself in cloud, it is just a matter of clicking one or two buttons. Or you want to create a database. A database is a place where you would save your data. If you want to buy a database yourself, that is also a matter of clicking one or two buttons. Or you want to create a storage in your cloud, right? Anything you want to upload or download files. So whatever service that you are looking for, you are getting that from a cloud computing provider as a service. And it is instantly created, and it can be deleted if you want. So this kind of computing
Sir,
is
could you
called.
repeat once again, sir?
Mhm. Yeah, Kumar,
Could you
come
repeat
again.
once? My system got stuck. I didn't listen that one. Uh, could you repeat once again?
No, what I said is, now with cloud computing, what you do is, you are getting everything as a service. For example, you need to buy a machine.
Mm-hmm.
Probably it is all about clicking on a number of buttons and you get your machine. Or probably you want to create a network, uh, just like your computer lab network or a office network. Like that, you want to create a network in the cloud, and you want to put the machines in that network. Again, that is also a matter of clicking on one or two buttons. So what I said is, whatever services or whatever, even if it is a machine or even if it is a database or maybe a hard disk you want to purchase where you want to save your data, or whatever things you are looking for, whether it is a machine, a network, or it can be a service, you are getting all of them as a service in a matter of seconds or minutes. So that is what a cloud computing is. And nowadays, AWS, Amazon Web Services, is the full form. They are the leading cloud computing provider today. Actually, they are giving you a wide variety of services. Whether you want, if you want to create a machine, you want to create a Windows PC or Linux computer, you want to buy it from them. It takes 2 seconds to create it, 2 or 3 seconds. It is that much fast and flexible, and you pay for only the hours that you use. Let's say you created one machine and hourly charges are $0.01 per hour, and you deleted the machine in the next 1 hour. You pay only for 1 hour, right? So you have that flexibility on the payment also. So you are actually paying for the hardware that you are currently using. Actually, that is how they split their pricing into. Let's say you want uh, 8 GB of RAM and 4 CPU computing power for next 2 hours. You buy a machine with that much power and you pay only for that computing power for 2 hours. After 2 hours you delete it. So that's how their pricing works. And also, whenever you want to create any services, you can create it, and all the services that you buy from them is like a pay as you go pricing strategy. That means only for the hours you need to pay. So these are different services that we are going to cover in AWS. So basically, even if I explain these services right now, you might not get a clear idea. Initially we will start with the basics. What is a web application, what is a software, and everything. Then we would actually set up our architecture in cloud. Our software, we would set it up on a cloud infrastructure. We would each of you would create your own AWS account, and in that account you would use their services to run some application, some Java application as well as some PHP applications. We would run it on the cloud. Then you would get a better overview. Okay, so that is pretty much about cloud computing, and I will talk about DevOps. So when I talk about DevOps, again I will give you a high level overview what is DevOps and what are the problems which DevOps is trying to solve. Rather than going into much technical, I will tell you what is DevOps. So nowadays the company, whenever they develop a software, they develop in a incremental way. That is how the development strategy nowadays is. Earlier it was different. Your customer would come to you and ask for a set of requirement. For example, he want to develop a cab application, and he would say he need an iPhone application, one Android application, one driver application. So driver will be able to accept the booking from his application. Passenger will be able to book a cab from his application, and passenger should be able to see the driver in the map, and he should be able to track the driver. He should be able to make a payment using credit card. So probably a list of features customer would give you, and you as a team, probably you will have a team of developers and also some testing and some IT people who take care of setting up. Developers would take care of writing the code to turn this requirement into a working software, and this software is typically tested by a testing team, and finally it is deployed into a working environment, maybe in a cloud environment, by the IT team, operations team. And so, but the whole process would take a lot of time, because a lot of development work is included, a lot of testing needs to be done, and a lot of work should be done by the operations team before they can make this software available to people. Probably it can take maybe an year to get the complete features implemented. So nowadays people don't follow that strategy. Now the software development firms, or if there is a company who want to develop their own software, what they do is they would just start with a very basic feature. For example, if you need to develop a cab software, initially you would find out what is the core feature that would add value to your business. For example, if it is a cab application, you would think about, let's develop a Android application using which people on Android phone can book a cab. Probably it is just a basic, I mean, you get is a book button and mention your location, right? Probably you need to select your location from a map, and then you click on the book button. You won't probably get a lot of options which cab you want to choose or how much time. Nothing, you won't get much options. All you get is a book button using which you can click on the book button, and an SMS would be sent to the nearby driver will be able to see the number of the passenger. He will call the passenger and they will communicate each other and they will travel. Of course, it is a very basic minimum featured software. It does not have a lot of things, but you good thing is that you are going live, you are going to the market in 2 weeks, because that's all it takes to develop such a basic feature. So the good thing is that when you are working on a small feature rather than working on the complete software, things are very easy. Even it is for the developers or the testing team, or even if it is for the operations team who is taking care of setting up the infrastructure where the machine will run. I just discussed about a infrastructure, a set of machines where your software is going to run, right? So the operations teams is the ones who would put this code into that working environment. Now people can see that application. So when the work that you are doing is very small in size, it is very easy for each team to work on that. And that is the strategy nowadays software development teams are following. Initially they would add a small feature, then next day or next week they would work on adding few more feature. So they would add very small features, and incrementally your software will grow. Probably maybe after 6 months only you would finish adding all the basic features that you needed to add, and you will never stop it. Maybe you won't stop at 6 months, you will have more work. You may want to add more features to your product to keep it up to date, and you also need to do some fixes. Sometimes the developer might have made some mistakes, so you need to fix them. So it is a continuous process. Software development is a continuous process that never stops. All right, so it is not as simple as I said, actually. Of course, companies are following this strategy. They are adding very small features. So what developers would do is developers would get the work. Maybe some business team asked the development team saying that we need to implement credit card payment option in the cab application. So please work on it. Probably other request came from a testing team saying that when we tested this software, we found that people from Bangalore are not able to book a cab. And there is some other request from the business saying that there is a immediate problem. Our competitor is implementing a lot of features and we need the same features to be implemented. For example, driver tracking, passenger should be able to track the driver. So there are different requests come from different teams at any point of time when you work with a development firm. So individual developers would work on these issues, work on these requests, right? And they need to make changes and everything. So all they do is they need to edit some code. Basically, your software is nothing but a program that your developers had developed, right? So each developer need to make some changes in the code, or maybe add a component to your software just by writing the code. So they keep on making modification to the application code. Probably it is written in Java or PHP or C or C++, right? In any programming language. So the developer would continuously work on this code and they keep on making changes, right? And all the changes that they are making, they would put those changes into a common storage place. I'm going to call it a repository. So any code changes that is happening to your project is recorded in this repository. whenever a developer is making a change, he is making a commit to this repository, and at that time the repository will record that commit. For example, who made that commit, and which files were modified, and what content were modified, and at what date it happened. So everything this repository will record. So the repository will get commits from many developers who are working on different job. So this is a smart storage, I call it repository, and or I can call it Git, which is an example of a repository. So this repository will contain the history about your software in 2014, who on January 2nd, who made this change, or which files were modified by him, or right. Also, the complete information about the previous changes are recorded in a repository. So developer keep on making changes to this repository, right? It is a continuous process. Like I said, you add more features one by one to your software. So any changes that is happening to this repository, first, and you have a infrastructure, right? Probably think about, you have a infrastructure in the AWS cloud, and this machine need to get the update from the developers. So basically developers make changes in the code on their local machine, on their laptop, they are making this modification. These code changes should come to these machines. Probably when you try to book a cab, you are actually going to hit one of these machines to get your cab booking done. So any people on the internet, whenever they try to book a cab, they will hit a machine that is part of a production infrastructure, production or live infrastructure. Some people call it production, or sometimes it is called live. Both are same. So there are a number, maybe there are 1,000. If it is a Google website, there they needed 10,000 machines that can serve these many people. So there can be a number of machines. So all these machines need to get this code changes from developers. Then only they can, let's say Tom, there is a developer called Tom who is working on this credit card integration. So he made the code changes. He put those changes in the repository. But as long as this changes in the repository is deployed into this machine, right? Unless this is deployed into these machines, people who try to book a cab will still don't see that credit card payment option. So this code need to put on these machines. The code changes, latest code changes should be deployed or released. I am going to use the term release. Release is a process using which you would make the changes of the developers available to your production or live infrastructure that is serving people on the internet, your customers. So it is not a simple process actually. Whenever developers are making changes, you need to bring it all the way to production. It is not a simple process, like I said. First, this plain text code. These are text file, right? You open when you wrote your first C program, you wrote it in a text file, right? It was like a test program. So first this program need to be compiled into a compiled form and need to be built into an executable code. So out of this source code, you would you would build it and you would create some executable code. Example would be the exe files in Windows, or the war file, the Java executable runtime files, then some Debian packages which can be directly installed on a Ubuntu machine. So basically these are the compile calls. Basically it can take care of some action. So if you simply double click on that exe file, probably it would do some action. So first the code need to be converted into an executable code, and this executable code need to be put on a testing environment. For example, you simply do not copy your executable code into your live machines directly, because any developer might have made some mistake by accident. And if you directly copy these executables into the production, you are actually copying the developer's mistakes also to the production, which is not a good practice. So what people would actually do is they would set up a small environment within their office. Maybe it would contain 5 or 10 machines, but you can actually book a cab using this environment as well. But this environment is only private to your office. People from outside world or your actual customer, they cannot book a cab using this environment. They should always use the production or live environment, but this is just for your own testing. Let's say there are some testing team in your company. So on their mobile phones, what they will do is they will point their mobile phones into this particular environment, and then they will try to book a cab. Let's say they want to test that the credit card payment is working. So they will point their mobile phones into this environment, and they will try to book a cab and try to make a payment using credit card. So they will do such test. Whatever developers are working, they will test it on a testing environment, and if everything is looking good, probably they want to test it again on one more environment to make sure everything is looking good. So finally, after all the testing, you would move the code into the production environment. So there are a lot of complexities. Whatever I talked about are little of them. There are more of them, which I'm not going to explain in detail. So what I said is the release process is always complex. So as the release process became more complex and complex, what companies do is they would delay the release process. They would think that, okay, if I am doing the release now, I am expecting a lot of issues in the next 3-4 days. So but nowadays a lot of people are using my application, so I don't want to do that now. Maybe I will do it next week. Next week I have a less traffic. So based on different conditions, people would delay the releases. Or sometimes you would think, you need to put your website down. If you are doing a release, I need to put my website down for 4 hours, because the release would take total 4 hours, so I need to put my website down. So it is not a good idea that I would put my website down in the weekdays. So maybe I will do it on Sunday. So probably this is the situation nowadays. For every companies, they have a complex release process, and they cannot do it something like part of their job. And it has a lot of disadvantages in terms of business, as well as the teams, the way the teams work. There are a lot of difference. One business problem can be, let's say you decided that you would implement credit card payment option because you have a competitor who is providing credit card payment option to customers. So people started moving towards them because that is more convenient. All they need to do is save the credit card in the application, then automatically whenever they book a cab, automatically the money would be deducted from their credit card. So people find it more convenient, and a lot of customers are being washed out to the other competitor. So there is a serious business problem. So you said to the developer, one of the developer is starting to fix that in your application also, so that people who is using your application would also be able to book a cab using credit card. And the developer, maybe he took about 5 or 6 days to fix that, and he put his code changes into the repository. But of course the release process, you are afraid of it. So what you would do, you would delay it. Maybe now it is not good to do it next month. Probably the companies do that once in a month, once in a 2 month, or maybe once in 4 months. There are still companies who does releases once in 6 or 9 months. So the developer who fixed this code, his work is still on the repository. It is not available to the people yet. It is more like a waste of work. I mean, as long as this work is not available to your customer, it is as same as a useless work. Or probably if I could have put this work into the release today, I could have saved my company, because after 4 months, probably I would have already lost a good amount of customers. So these are very serious business issues. If you are not able to make changes to your applications in time, or you are not able to do the releases in time, that can cause serious business issues nowadays, because nowadays the market is very dynamic, and most of the companies are moving towards DevOps, and those who already have a good DevOps culture implemented, they are doing it very fast. Maybe they are making changes to the application every day, or maybe once or 10 times every day. And there are still companies, Flickr is one company, they do releases every day 10 times. They are making changes to their application based on business demands 10 times per day. And nowadays the retail companies or any companies, right, they what they do is they do some real-time marketing search, and based on what they find, they will make changes to the application immediately. For example, think about Flipkart. They find they have a lot of items in the stock, so they need to clear the stocks immediately, otherwise it is just a waste of money, and they are going to it's not good. You don't have enough place to keep them in the stock, so immediately you would start giving discounts. So based on what you find, you immediately fix those issues in your code, and you would do a release, and immediately people will now find discounts on the items that are in the stock. So this is kind of a business requirement today. It is a mandatory business requirement today. If you want to stay in the market, you should be so dynamic and be able to update your applications in time. And that is where DevOps comes into picture. DevOps would try to put in a lot of automation. There are different tools available. There are tools, the repository tools to which people can, upload their code into. And there are some build tools. Automatically, developers uploaded their code into a repository. There are some tools which would automatically pick up these codes and build this code into an executable code. And there are other tools which will monitor this executable files, and if there are new executable files, immediately it would deploy those executable files into a testing environment. And as soon as a deployment is triggered in a testing environment, there is another tool that would listen to this, and if there is a change in the testing environment, it will trigger the testing tool. So a automated testing tool will do the testing. It will try to book the cab, or it will try to make a payment using without human involvement. It will try to make a payment using credit card and everything, and finally it will generate a test result. If everything is looking good, whichever had failed, it would report. It will make a list of the report. Whichever test has failed, whichever had succeeded, it would make a report, and immediately there are some intelligent tools that would read this report, and based on the report result, it would make a deployment into the production and live. So like that, you have a lot of ways. Nowadays a lot of tools are available. Ever since this DevOps term had evolved, there are a lot of tools available in the market that can help you do a lot of automation. So your job as a DevOps engineer would be just make this possible.
Hi,
Yeah.
Basil.
Yes.
Hi, this is Shakib here.
Hey.
So, in a simple way, what I understand here, like we get the feedback from the customer. It could be enhancement, it could be bug, it could be new features, right?
Yep.
So those thing has to go to developer, right?
Yes.
In order to like add the features, or do some kind of enhancement to our product, or any kind of bug, they need to rectify that. So it should go to developer as soon as possible. Then it go to, once they develop the product, they made the changes in the code, and again it has to go to delivery, right?
Yes.
So then delivery, I could say that it could be in an ops team, operations, and then they will do the certain process and follow the process, and then finally it go to production. So these process, generally we used to you know do these process through different engineer, right? I mean, we assign the people, like this is the testing guy work, and this is the QA guy, and then the developer. So those things has to be done by through DevOps, different kind of tools. They will, tools will do the things for us, right? Instead of involving the human,
Yes,
uh,
not exactly. Yeah, go
yeah.
ahead.
So these whole process will be done by the through DevOps kind of. It's a development and combination of operations, right?
Yes. So I will tell you a good question. So not exactly. So what actually happens is you will have different teams. You have developers and you have operations team and you have testing team and you have business also. So when you
Okay.
work in a DevOps culture, all of them will work together. For example, DevOps development team need to understand what are the business priorities, what need to be delivered first, and what can be delayed. So developers would have that understanding, and the operations team, rather than they are manually setting up the testing environment and managing the infrastructure, they would automate that. Basically, the creation of this testing environment where the developers want to do some testing. So you would set up some way of automation in that, so that automatically whenever a code is changed, a new testing environment can be instantly created where developers can instantly start testing. So there is no need for developers to wait for operations team to finish their job. Kind of,
Correct.
probably, or maybe developer made some code changes, they click on a button and automatically a testing environment got generated itself where they can start the testing. And
Mm-hmm.
even along with developers are writing these development changes, where they are making some changes in the code, the testing team would work close with them, find out what are the test case that need to be written. For example, there is a developer who is making changes and he is adding credit card feature into the application. So the testing team immediately write a test case which will try to book a cab using credit card. And
Mm-hmm.
instantly there would be some tools. There is a central tool where the testing team who wrote these test scripts, they can put their test scripts into. And there is a central tools, you can call it a continuous integration tools. An example is Jenkins, and that is one of the topic that we are going to learn. So Jenkins, at any point of time for each releases, Jenkins will know which scripts need to be tested for this particular release, because the testing team had written job for that specific releases. So it would be basically like all teams need to work together, and a DevOps engineer, there is a role as DevOps engineer. Their responsibility would be making this release process as simple as possible, either implementing a lot of automations into the infrastructure and also like testing environment creation, right? So it doesn't mean that
No, I
there
can
are still
understand,
separate
but
teams.
yeah, I understand your point. But as a QA and tester, and also as a developer, they will be able to grab the things in a fast way because they were working in this kind of environment. Because if as a infrastructure guy, as a support production support guys, he never worked on development life cycle, and he never worked on QA. He won't be able to write a test case, right? So if I'm coming as a production support and infrastructure guy to DevOps, to switching my technology and want to build my career in DevOps, so what would be the role on me, and how it I can grab the things and like instead of get into the developing concept and then QA concept, and what would be my role in DevOps if I'm switching to DevOps?
Yeah, I got your question, but yeah, again, good question. But it is not exactly all this process has evolved to become the software process more simple, the release process more simple. It does not really I mean, it doesn't say there is no need of operations engineer anymore. They have role. Their role is to make the best deployment practices, right? And even these tools are unfamiliar to both developers and testing team. It is the tools are being managed by you, right? So you are the one who is like the central focus where developers and a testing team or any other business team would rely on. So basically, the tool you are setting up, there is one tool that you are setting up that takes care of installing the software on individual machines that is in the cloud. So there should be a person who need to manage those tools or managing those automation pipelines. So it is not something like there is no need of operations engineer anymore. That is not the case, but the operations, the way of working is being upgraded nowadays into these automated practices. So as
So
a
you're saying
DevOps
the
engineer,
person would, DevOps engineer would be a mediator between developer and then operations.
there
Like we
is
can who can
no,
understand the
yeah,
development, what developer is saying, and accordingly he can do the things, or he can facilitate the some of the, because generally developer doesn't have access to production, right? So I mean, he can involve getting the things done, and facilitate to the sometimes to the developer, right?
exactly,
Get the things
exactly.
done.
That is the limit of a developer and testing team. Their limit is they can write the test scripts based on the process. But as a DevOps engineer, the role can be
Okay.
anything. It is not just a simple role where you would manage a single testing environment or you would manage a single production environment.
So
It
he's
can
like
be
admin.
anything. It is more like a admin. Yeah, it's more like admin job. So
Okay.
basically, you work towards the delivery of the software as early as possible. So those kind, and it can even include
Yes.
the traditional work as well, the traditional operations work which are going on nowadays. It can include that also. That is also not being eliminated because you need to have the admin works to be set up. You need to install some software on a machine. It should be installed, but this time you would do it once time manually, but maybe next time you won't do that manually, you would automate that. And finally, and after some time, you realize that you need to add some more monitoring, or you want to add some more software component to be installed. Maybe first time you would do it manually,
So
next
these
time you
things will
would
be done by
automate it.
tool.
Yes,
All those things, whatever you're saying, it's gonna be done by different tool,
ideally yes, but practically
automation.
there are some limits for automation everywhere. So sometimes there are some manual
Okay.
work which you may still need to do, but ideally you work towards a complete automation, which is never possible.
So what I sense that as a DevOps engineer, as you said, as admin, so he will work on a different level, and also you know um enhance their skill set into different uh, domain, because they need to understand the business line, they need to understand the operations, they need to
Exactly.
understand the developer language. So I mean, it's like multitasking kind of, the person should understand, he will be all rounder, correct?
Ideally yes, but again, like I said, that is not the situations in all the companies. But an
Okay.
ideal DevOps engineer should have a clear understanding about the business as well, even including business, the
Okay.
priorities, what should be the
Correct.
business priorities. So that is also important. But
Yeah, it
that
depends
should
on the
not be different.
companies.
It
Yeah,
depends on the company. So kind
depends
of.
on how big the company. Yeah.
Yep.
Yeah. I got your point. Yeah, thanks. Yeah.
Yeah. No problem. So yeah, I hope that we discussed this. So Basically, that's what even I was coming into as well. I just wanted to tell to all. So this is the role of a DevOps engineer. Basically, you would work towards sometime the work would be you have a number of machines and you want to install a number of software on those machines in a automated way. So how you would do that? Or another situation is you want to uh, you realize that you need a different software to be installed on all your machines for a particular release, and after that you want to revert it. So in such situations, what would be the job flow? So typically, I mean, I don't know, even if I am talking these things right now, it would be looking like a foreign language to you. Don't worry about that. Basically, we are going to do this in our course. We would actually take some sample project and we would practically implement these things, uh, right? Then you would get a better idea. What I'm saying is, don't worry about too much on the things which you don't understand, because most of you probably don't have an idea about the software yet. So which we are going to, which would get fixed. So other than that, and we are going to start our hey Pawan, good evening. I think you joined a little late, right? So anyone else joined a little late and want to discuss something, right? And remember, you will have, like I said, there are many tools that we are learning, and initially we should be in a very good pace. Whatever I am teaching, you should be able to understand and bring up with your questions, even if it is very small doubt. Clear it and go. And make sure that, especially when we are covering the basics topics, the first 2 weeks is about the basics. You should be have a clear understanding on all these. Otherwise we cannot really proceed with enough confidence, because these are the foundation where we are going to learn our advanced topics. So all the assignment or all the practical work which I am doing in the class, on all the assignment that I am giving you, make sure that you are completing in a daily basis. It's very important, especially if you are a fresher. You should absolutely do all the assignment on a daily basis, and then things would be easy for you after this first 2 weeks. So very very important. I insist. There are, I mean, because I have seen there are still people who won't give much focus initially, and that can result a real problem. So whatever assignment, or sometime I would ask you to read something, attend the classes every day. Whatever work I am giving you, do it and follow it in the right way, and then the course would be very easy. It would be very easy if we are following the right pace. So that's very important. And also the classes are recorded. In case if you miss some classes, make sure that you are watching the recording and make yourself up to date. And you need about 1.5 hours for this everyday training, and probably 1 hour extra for working your assignment. So maybe if you are already working somewhere, find your time, I don't know, maybe start your day 1 hour early, or I don't know. So just make sure that you have enough time, you are finding time to do your work and stuff. At least if you cannot cover on a daily basis, at least make it up on a weekly basis. On use Saturday and Sunday to cover if something you missed it. So just make sure that we are in pace. So that's important. And at the course, like I said, it is 55 hours, and everyday classes would be from Monday to Friday, same time, 9 p.m. Those classes, actual classes, starts tomorrow. Today it was again a demo. So tomorrow is when the actual classes starts, and every classes would be recorded, and you all will get access to the videos as well. So make sure that we are in pace, and by the end of the training, we will have some session for preparing for the interview. And this is a job-oriented course, which you know. So it's a practical course. So at the end we will have some class for interview preparation and stuff, and what project you need to work on before you prepare for your interview. And most of the assignment which I am giving are like real-time work, so that is why the assignments are very important. You can actually present that as a work that you have done. That would give a very good visibility to your resume. So yeah, so that's pretty much I wanted to discuss. Anyone else any questions? So the class starts tomorrow, same time, 9 p.m. Yeah, go ahead if you have any questions. Okay, so cool then. And one more thing, like I said, it is a very good job. Kind of every companies are moving towards DevOps. It is now a mandatory thing. Every companies has to adapt DevOps if they want to stay in the market. So the even that add a lot of job opportunities, and the job opportunities are huge, and they are highly paid jobs. The DevOps, most of the jobs, DevOps engineer roles are in production companies and startups, and they are highly paid jobs in India and as well as in US. It is very good. So yeah, I think that's pretty much. Yeah, see you all tomorrow, right? Yeah, thanks. Bye.
Yeah, thank you.